All right, so today supposed to be endurance day. I did semi endurance. Had just like another like walk and talk with one of the guys I work out with. We walked kind of a couple, um, it was like 6 blocks maybe, down and back to the clinic where I work at. But yeah, so again, just like I said, taking this week kind of chill, trying to settle down and get prepped for the end of the semester. But today we're going to move into talking about, we're going to start talking about resistance training. So when we look at resistance training, the number one thing that we're kind of examining and looking at is percentage of one rep max. So how on our curve, how much force are we able to produce, basically, and how little can we do to produce that much force? It's the general idea. And the goal with these adaptations in general is to make whatever weight you're pushing feel easier by making it our recruitment less than normal. So there's going to be two main adaptations we see with resistance training. Number one is going to be neural tuning. So that's going to be the very first adaptation that we see. So that's going to be like you're smoothing out a movement. You're just rewriting movement patterns, syncing everything up to make sure that the movement is nice and smooth. You're not getting like hitches in your squats and stuff. Next one is going to be increasing the contractile unit, specifically sarcomeres. You're going to be increasing the amount of sarcomeres that you have, or not the amount, increasing the size, I should say. How we're going to do that is muscle or myofibril hypertrophy. So you're basically going to be adding in parallel, so either adding lengthwise or girthwise. The fibers that we see mostly susceptible to this are type 2. There's also like hyperplasia, which is you can actually add the number of sarcomeres that you have, but it's really rare in humans. You really see it in a few animals. And another thing we're going to see with that is actually an increase in the number of nuclei being like recruited or brought in. So those little satellite cells that sit on the top of muscle cells, you'll actually see more of them kind of dive in, so that it's not one CEO with 1,000 workers. It's a CEO and then his 3 or 4 executives, and they have their own bosses who have their own bosses. Kind of like that. There's just more things to regulate. And one that we can see, it's not really one that we look at too in depth, is an increase in bone density just because of Wolff's Law. If you're doing heavy compound weights or weightlifting, like squats or deadlifts, bones are going to kind of bend, so your body's going to work to strengthen those bones up.